Does anything match up in the two triangles? So yeah, Avery?
Well, I said that they are congruent.
Okay.
Because,
Bless you.
so if I found the third angle of DEF.
Ah, okay. So we find the third angle by doing what?
I added 74 and 61 and then subtracted that from 180.
Sounds good to me. Okay. What'd you get, 45?
Yeah.
Okay. So now with that given additional piece of information, do we have an angle-side angle congruence for these two triangles? Yes, we do, right? Two angles and the included side are congruent or equal to two angles and the included side. So without having to find the measure of these two sides or these two sides, we know they're going to be equal. AB will correspond to what over here? AB will be corresponding or congruent to what side over here? DE. And BC will correspond or be congruent to EF, right? Okay. Easy way to identify that, all right, is, well, this is going to be a 74-degree angle. So, right, if AB is between the 45 and 74, then that means DE, which is between the 45 and 74, will be congruent to the AB. Likewise, BC, if it's between the 7, that looks good too. Between the 74 and 61 is BC, between the 74 and 61 is EF, so they will also be congruent or equal in measure. Okay? All right. So let's take a look here at this next one then. These two triangles. Okay. Can we say that they will be congruent by an angle-side angle congruence? And what should we do here? Jenny, what should we do? Or you want to say no right away?
Yeah.
Okay.
I added up 31 and 38.
Okay, so that's 69 degrees, and then what?
Subtracted it from.
Subtract from 180, what does that leave us with? I think it's 111, I think is what it is. Okay, so yeah, that's a problem, right? Because what do we want that 111 to be? We want it to be 110, right? So these two triangles cannot be congruent, and so then therefore there is no angle-side angle. You could also solve for it here. I think you would get 39 degrees here. So you can see that there's just the one side that we have is 62, but that's between a 31 and 110. This 62 is between a 111 and a 31. So it's not angle-side angle, so we can't say they're congruent. Okay, in fact, they are not congruent. Okay, so there's some basic application of angle-side angle. Okay, trying to show the triangles are congruent. All right, so turn the page. Okay, let's take a look here at number 5 real quick, and then we'll move on to an actual proof. Given the picture there at number 5, can we determine whether those triangles are congruent or not? At number 5. Given the picture we've got there, can we determine those two triangles to be congruent or no? Avery, what do you say?
We can.
Okay.
Because you know that the right angle is going to be supplementary to the adjacent angle.
Okay, so this is also going to be right, is what you're saying there?
Yeah,
Okay.
and then with the little arcs, you can tell that the angles are congruent there.
Okay.
And then with the tick marks, you can tell that the sides are congruent.
So angle, angle, and the included side. Angle, side, angle, right? And a side between them. So angle, side, angle is congruent to angle, side, angle. So yes, the triangles are congruent. So we'll say triangle ABD is congruent to triangle, and then if we named that left triangle ABD, how must we name the second triangle? ACD. Right, corresponding pieces. If we went from A to B to D, A to B to D, then I have to go A to C to D to match up the corresponding pieces by, angle, side, angle. Okay, angle, side, angle. Okay. What other piece here can we say is congruent just from looking at the picture alone? So what other piece will be congruent in this triangle as well as congruent in this triangle? What other part of this triangle can we guarantee is also going to be congruent to this one just by looking at the picture there? Madison?
Angle A.
So angle A? I see. I guess you're right. They would have to be, right? Because if those two are given angles, then the third angle will also have to be congruent too. What I was trying to go to, but you're right. What I was looking at there was AD. Side AD is shared by both, right? AD is the side of this triangle, but it's also a side of this triangle. So AD is shared by both. It's going to be the same length. Okay, so we can also use that side as well to show there's some congruence there too. Okay, so let's proceed on here and take a look at an actual proof. All right, the first one is already done for us, but we'll kind of like work our way through it. Okay, this is going to be one of the major pieces, major components of this unit that we're going through right here is proving triangles congruent. Okay, we want to use these congruences that we learned. We only have one triangle congruence we have to worry about right now. It's angle side angle. We'll grow in those numbers of congruences later, but first just angle side angle. Okay, so again we start out with given information. My recommendation is to label your diagram with the given. Label your diagram with the given. Okay, so angle MQP. So angle MQP, the vertex is Q, so it's this angle right here. I'm going to use a little arc. Is congruent to angle NPQ. NPQ, it's this angle right here. Okay? MPQ, this one, I'm going to use two arcs there since I already used a single arc, is congruent to NQP, this angle right here. We're then trying to prove that triangle MQP is congruent to triangle NPQ. What other part of our triangle here can we go ahead and say will be congruent? Madison? Yeah, segment QP, line segment QP is going to have to be congruent because it's shared by both triangles. Do we have an angle side angle congruence now? Yeah, right? Angle side angle is congruent to angle side angle. And so you can see the proof. They state the two givens. Then they stated just what Madison said right there. QP is congruent to QP. Segment QP is congruent to segment QP. How do we know something is congruent to itself? It's the reflexive property. Remember those, right? And then we have angle side angle, right? There it is. So we can say the two triangles are congruent by angle side angle. And we're done. That's the proof. 4 steps. Okay, 4 steps. Easy peasy. All right. Questions on any of that? All right, so let's go to letter B here, which has some of our training wheels taken off. Not completely, right? We've got some statements. We just have to give the reasons. So let's again go to our given and let's label our diagram. Angle A is congruent to angle C. So, okay, angle A, angle C, got it. Okay. E is the midpoint of segment AC. How should I show that? What can I do? What congruence then do we have? If E is the midpoint of segment AC, what can I mark congruent here or equal in measure? If E is the midpoint of segment AC, what can I mark to be equal or congruent here? Jake? A, E, and C. Exactly right. Can I go ahead and mark EB congruent to ED? With the given information that we have, we don't want to mark them congruent. Of course, later, once we prove the two triangles are congruent, we know that EB and DE will be congruent, but for right now, using only the given information, we don't know that E is the midpoint of segment DB, and so we don't want to use that just yet. Okay? With the markings that we have here, do we have enough information to say that we have angle side angle congruence? I only see an angle and a side congruent to an angle and a side. I need one more pair of congruent angles here. Is there some other pair of angles we can mark to be congruent based on the diagram? Some other pair of angles. Emmanuel, you see something? Yes, at angle E. Why do they have to be congruent? Because they are what? Remember the vocabulary term for it? Starts with a V. Vertical. Vertical angles are going to be congruent. Great job. Yeah. So that angle there at E, AEB, DEC, have to be congruent. Now do we have angle side angle? Yes, we do. Okay. So now we've got all of our things listed. Now we can go through our statements and reasons. So angle A is congruent to angle C. How do we know that? It was given. Okay. E is the midpoint of segment AC. How do we know that? Given. AE was congruent to EC. Okay, Jake, how did you know that was the case? What piece of information did you use? What piece of given information did you use? Yeah. Yeah. That's all you got to do. E is the midpoint of AC. Okay. If we want to say like definition of the midpoint there, that would be acceptable too. Okay. Definition of the midpoint, that would be acceptable too. Okay. But you can also just use that previous statement as a reason. Okay. How did Emmanuel know that angle AEB was congruent to angle CED? Because they were what? Yeah, so we can just, I'll just abbreviate some here. So vertical angles are congruent. Okay. There's our angle, there's our side, there's our angle. Angle, side, angle congruence, right? Angle, side, angle. So the two triangles are congruent by angle, side, angle. Okay, that's it. These proofs aren't that bad. They're pretty straightforward, okay, once you label your diagram correctly. All right. All right, I would like to do 8, and then we'll have you maybe try number 9, okay? So let's do 8 here together. Let's do 8 here together, because this one's a little bit funky because the triangles are overlapping. All right, and you got to be careful here about what triangles we're trying to prove congruent, right? Because I see like four triangles here, right? I see this triangle. I see this triangle, but I see the big triangles here too. I guess there's really 5 triangles. We've got one in the middle, okay? The good news is they didn't name this point right here. They didn't name this point, and so we can see then it's got to be this big triangle. And you can see right here too, JML, JML. So it's this big triangle we're trying to prove is congruent to KLM. Okay, so we have some given information. Angle JLM, this angle, is congruent to KML, this angle. JML, okay, so that's this angle right here, is congruent to angle KLM, this angle right there. Okay, it's kind of annoying that these triangles overlap like that. Do we have enough information marked on our picture here to have an angle-side angle congruence? I see 2 pairs of congruent angles, but I don't see a pair of sides congruent yet. But Avery, what do you want to say? That's right. LM is shared by both triangles, so it's another reflexive property right there. We can just mark those as being congruent too, to themselves. Okay? So, what's going to be our first statement? It's our first statement here. What's the first statement normally? The given, right? Yeah. So, Aubrey, what would it be? Give me the statement.
Angle JLM is congruent to angle KLM.
Okay. If you wanted to, you could give the other given at the same time here, if you want to. That's up to you. Okay. I think looking at the number of steps that they have for us in the table here, I think they want us to do the givens in 2 separate steps. If you want to do it all in one step, that's fine. You just won't use up the whole table. And that's okay too. If you prove it without needing all the parts in the table, that's fine. If you need more than the parts that are in the table, that's fine too. All right, but we'll just go ahead and do it in 2 steps just because I think that's what they want here. Okay, so we have our 2 angles. What do we still need to declare to be congruent here? The side. So we'll say that LM, segment LM, is congruent to segment LM. How do we know something is congruent to itself? By what property? Reflexive property. Okay, and then what's our final statement here? Steve?
Triangle JML is congruent to KLM, or triangle KLM.
Beautiful. Exactly right. The thing we're trying to prove. The last step there, right? That's the thing we're trying to prove. And what would our reason be? Angle, side, angle. Okay? You don't need to spell, you don't need to write the word congruence there. You can just say ASA. That's fine. ASA. Okay. Questions on any of that? All right, go ahead and give number 9 a try there. Okay, this one's a little bit tricky, but I think we'll be okay. Okay, so give number 9 a try. Okay, give number 9 a try there. Again, mark your diagram first. Mark your diagram first. But give number 9 a try there. I'm going to have you go in it cold turkey here. Your proof should have 3 stated congruences in it. Okay? If we're trying to use angle side angle, you need to have 2 congruent angles and 1 pair of congruent sides. So use your diagram to help you there. If you're really not feeling the proof, at least try and get your diagram marked correctly. So if you're not feeling the proof, try and at least get your diagram marked correctly. Okay, very big. This is RB is bisecting SC and ST is congruent. So you have to state that congruence, right? You have to state that. So say ST, second ST congruent to. What's the piece of information that allows you to come up with that? That RB bisects ST. Yes, exactly right. That would be your understatement of reason. And then S is for U because they're both right angles or something like that. Okay. There should be reasons. I mean, and again, this is a situation where you're right. I mean, really, who's going to question that? You know, but I think again because so it's more like because where you guys are, we want to make sure we have those 3 congruences stated. But would I take points off if you did this congruence and then that vertical angles and then just jump right there? Probably not, but I would like you to state the 3 congruences that then allow you to see the triangle. You can use 3-letter names there, like you just said, or you can just use a single letter because really, if you just say angle S, there's only one angle, that angle S you would use. So you can get away with just the single letters there, but if you want to use the 3 letters, that's fine. Probably a better bet in general, right? So yeah, no, good job, Jenny. Well, so what do we know about angle S and U? Yes, I would say the reason you know they're congruent is because they are both angles.
Okay.
You see what I'm saying? It's kind of like a silly step to take almost that you have to say that because they will they're both right angles and they're the same measure, right? But yeah. Okay. So this is good. The only thing I want to point out here is that we're told that RB bisects SU. So we're not told that SU bisects RB. So you see what I'm saying? So if we know just this, what are the pairs of sides that we can say are congruent? If RB is bisecting SU. So RB cuts SU in half. So it's going to fit in those 2 exactly right. And then can you come up with one other pair of congruent things then, based on the way the diagrams are going? So what else can we do right here? You could actually, you could argue that it would take a few more steps in the proof, but you could argue that. Why would you want to say that they were congruent? What would be your reasoning behind that? Okay, so in like I'll go over that. I'll talk about why that is, but there's actually easier pair of angles to see are congruent, and that'll be this angle and this angle. Why do we know they have to be exact? So keep an eye out for those kind of things. Keep an eye for those. Yeah. So it should be yeah. Be careful here because it's right. You're right. But number 4 is true. Number 3, that doesn't follow from this. RV is bisecting SU. We're not told that SU bisects RV. So RV is cutting SU into 2 parts. So we can only say that is true. We can't say that these are necessarily congruent. Do you see what I'm saying? What you said here for your reason, this reason for this is fine. That is the reason you're looking for. I mean, but you can't. What I'm saying is you can't, with the given information you have, you aren't able to say this. Eventually, we would say it must be proven the triangles are congruent. But this third step here is you can't state that based on the given information that we've got. So there's another congruence you got right there. It's the vertical angles. So you got 1 at 90 degrees, 2 ST and then SU, GU, and then 3 angle side angle. You don't even need RT. Okay. All right. Yes, I'll read, and then we'll go over this here, folks. Why do you did it wrong? So, reflexive property can only be used when something is congruent to itself.
Okay,
So this wouldn't be,
can I say distinguish?
well, so does it even look like this? Will be congruent.
Oh, I meant to do. I meant to do, wait. Can I say RS and
What would be your reason for that?
then they, can I use those 2 in the right angle?
Okay, so that would give you the angle S and angle U are congruent. Which are both right angles.
Oh, okay.
See what I'm saying?
Yeah.
And so then you can also get a congruence from this statement too.
Oh, okay, so I
See
can
what I'm
use
saying?
that for.
Yes.
Okay.
Generally, you're given information. If it's not already a congruence, you should try and pull a congruence from it.
Okay.
Okay?
Alright.
All right, let's take a look here at this. All right, so I'm going to take care of the easy part. We all know we need to state givens, so I'll just go ahead and do that. So step 1, angle S and angle U are right angles. 2, segment RV bisects segment SU. And both of those reasons are given. I took care of the easy ones. Okay? I also saw some people going around. They had already filled in to their final statement here. 1, 2, 3, 4, 5, 6. They had already filled in for their final statement that triangle RST is congruent to triangle VUT. This is an okay thing to do. We know that we're going to end at what we're trying to prove there. So again, should you be like in a quiz or a test situation and you want to try and like maximize the number of points that you could potentially get, for a question, even if you like aren't sure about everything, we know that's going to be the last step. So you could put that as your last step, and I would give you a point just for knowing that, right? Okay, knowing that's going to be the last step there. So that's good to do that, okay, if you want to. But we still got to fill in the rest of the proof here, right, to get the rest of it. So someone want to raise your hand and give me step 3 that we could do here? What would be a next step that we could say here? Do we have another step? Emmanuel, you think?
Would be on segment ST is congruent to T.
Beautiful. Segment ST is congruent to segment TU. Reason?
That's like what I was kind of like gonna ask you because I wasn't sure if you could use like RV bisecting ST does.
Yes, absolutely. Since we have this fact, we can now use it to state some other facts. And in general, I was telling Aubrey this, but I'll let you guys know this too. in general, when you are given a piece of information, if it's not a congruence, at least for these proofs where we're trying to prove triangles congruent, if you're given a piece of information that's not a congruence, chances are you will use it to get a congruence. So this statement, RV bisects SU, not a congruence, but then from that we were able to get this congruence. Now, what we can't say here is that RT is congruent to TV. We cannot say RT is congruent to TV yet, because RV is bisecting SU, but we're not saying that SU bisects RV, right? RV cuts SU into 2 equal parts, but we're not told that SU bisects RV, so we can't use that. Okay? So we've got one congruence. What's another congruence we can state here? What else is congruent? So I got a right angle there, I got a right angle there. What's another congruence here? Go ahead.
Angle RTS is congruent to angle VTU.
Angle RTS is congruent to angle VTU. So he's saying RTS, VTU. Why? Vertical angles are congruent. Okay? Last congruence. What do we need to state? It's kind of a silly congruent statement to make, but we have to make it. Okay, Madison?
Angle S is congruent to angle U.
Angle S is congruent to angle U because
Like, they're both 90 degrees.
they're both right angles. Yeah, they're both 90 degrees. It's kind of it's like so silly that we have to say it, but there it is. And so then finally, angle side angle is congruent to angle side angle. The two triangles are congruent by angle side angle. Okay, and there it is. All right, sorry I didn't give you very much time to get started on your assignment. Your assignment, okay, it starts on page 237. Number 4. 6 through 9. Okay, so you got 1, 2, 3 proofs there. One is just a fill-in proof, though, and then a proof on your own. And then 14 and, oh goodness, 14, 16, 19, 20. Okay, 14, 16, 19, 20. Okay. Only the 6 through 9 there are proofs. Only the 6 through 9 are proofs, okay? So don't fret, those are not all proofs. Only 6, 7, oh actually sorry, only 7, 8, and 9 are proofs, and 7 is just really filling in blanks. So really only 8 and 9 are like the full-on like proofs and stuff like that. Okay? There's only 2 full-on proofs, everything else is just kind of like, answering some questions and stuff. Alrighty. Yes? Yeah, if you want, sure. Okay. Any other set requests for today? I know we're running low on time here. All right, Jenny, I'm putting you in, of course, so.